This is part 2 of lesson 3. We're looking at example number 3. And if you recall from the last video, this is actually a real AP problem from 1990. This was the number 5 or the 5th problem from the 1990 AP examination. Okay, part A. It says write the first 4 terms in the general term of the Taylor series expansion of this function about x equals 2. There are 2 ways to complete this task, to construct the Taylor series centered around 2. One is you can raw construct, like we did in lesson 2. In raw construct, we would find that f of 2 is equal to 1. We would find that f prime at 2 is equal to negative 1. F double prime of 2 is equal to the number 2, and triple prime of 2 is equal to negative 6, and the fourth derivative at 2 would equal 24. Of course, I made it look easy by getting right to the point, but it'd be a little harder to raw construct that. The other way is to write this in the form of a geometric sum where it is centered around x equals 2. So if we said 1 plus quantity x minus 2, then you can see that these 2 fractions here are equivalent, but we would recognize this right away as a geometric. In either case, f of x is going to be first term 1 minus the second term, which is x minus 2 plus x minus 2 squared minus x minus 2 to the power of 3 plus dot dot dot. The question asks also for the nth term, so here we have negative 1 to the n x minus 2 to the power of n, and the series goes on forever. So that is the answer to part A. In part B, they ask for a Taylor series expansion for the natural log of the absolute value of x minus 1 using the series we found in part A. This A and B are really review. So this is going to be the integral, the integral from 2. Now I'm saying from 2 because it's asking us to construct it about 2 to x, and I'm being very formal, of a series that would be the integral of t minus 1 dt. So we found the series for this in part A, and now we're taking the integral from 2 to x of the series using a dummy variable t along the way. So this is going to be the integral from 2 to x of our series here in terms of t, t minus 2 plus t minus 2 squared minus t minus 2 cubed plus dot dot dot, and we take that with respect to t. Moving along, now we're going to integrate term by term by term. So the integral of 1 dt is t, funny looking t, minus, we treat this t minus 2 squared over 2 plus t minus 2 to the power of 3 over 3, continuing along, t minus 2 to the power of 4 over 4 plus dot dot dot, and of course we're going to use the fundamental going from 2 to x. This here is funny, that's a t. But when we plug in the x, it becomes an x, as do all these terms here. All the t's become x's. okay, to the 4 over 4 plus dot dot dot. So that's what we get when we plug in x, but now when we plug in a 2, the 2 contributes only to the first term, and then after that it's a bunch of zeros. Now this is a very formal way of writing it, but you can see here that you have the x over here and the negative 2 over here, and we can combine them. So x minus 2, quantity x minus 2 squared over 2 plus x minus 2 cubed over 3, continuing as follows. And the question again calls for the nth term. So we do see that this is going to strictly alternate. We have the alternating indicator. But when we take the antiderivative, we're going to have here x minus 2 to the power of n plus 1. See, if we take this n and add 1, it becomes n plus 1, and we divide that by n plus 1 plus dot dot dot. There we go. That answers part B. So now we're going to get to part C, and part C is talking about the error, which is really what this entire lesson 3 is about, is the error. Pardon me again. So it says, compute a number that differs from the natural log of 3/2. Compute a number that differs from the natural log of 3/2 by less than 0.05. Another way of saying that is such that the error is less than 0.05. So you will notice here that the natural log of 3/2 can be written as the natural log of absolute value of 5/2 minus 1. Plugging in 5/2 for x. So this means then that wherever I have x, I'm going to plug in 5/2. So 5/2 minus 2 minus 5/2 minus 2 squared over 2 plus 5/2 minus 2 cubed over 3, etc., etc., etc. Minus dot dot dot. Okay, so now if I simplify this, I have 1/2 minus each of these terms goes to a half. 1/2 squared over 2 plus 1/2 square cubed over 3 minus 1/2 to the power of 4 over 4 plus dot dot dot. And let's see, this gives us 1/2 minus 1/8 plus 1/24 minus 1 over 64 plus dot dot dot. And the question says compute a number that differs by less than 0.05. So we can say now that the natural log of 3/2 is approximately 1/2 minus 1/8, which turns out to be 0.375. Now here's the error part, with error and magnitude less than or equal to the first omitted term. First omitted term being 1 over 24, and 1 over 24 is less than the desired 0.05. It is important that each time we say this E1 error theorem, we say this is true because the series for the natural log of 3/2 is strictly alternating and decreasing in absolute value to 0. It is now time for you to try problems 4 and 5 from the notes packet. Again, that will be gone over in class. I will not provide a video for those two examples.